BGP scaling, and some miscellaneous topics. So that's what we would do now. The first thing which comes in BGP scaling would be, and all these topics which I'm going to discuss now, they are sort of independent RFCs in themselves. So as BGP is one RFC, many of these topics are themselves independent RFCs. So that's how big they become. But I will just summarize them so that you can have an idea what they are. Okay, so we have seen, so first thing is dealing with IBGP. So one of the first thing is how we deal with IBGP. So we have, for the time being, said that if I have an AS and if I have these are two external routers and that's one internal, and if I have them, I will have 3 virtual links on IBGP. That's right. So that's what I mentioned earlier. So green is writing IBGP, right? So I don't care if I'm not directly connected. So this way I create an overlay of IBGP and it is having an underlay of IGP, right? So they work together and we have seen how they work together, right? So we should be very comfortable with this concept now. The problem with IBGP is, as my network grows, scaling becomes a problem. Because then I have to build those many things, because what is the condition in IBGP in this case is full mesh. Why full mesh? Because BGP as a protocol wants the two neighbors to be directly connected. I want my neighbors to be directly connected, so the only way you can be connected would be full mesh. But full mesh, as I gave you an example, if you go from 3 to 300, connecting everyone with everyone would be really, really a headache. It's not scalable, it's not doable. Then we have 2 alternative solutions. There would be route reflector. Route reflector and configurations are the 2 alternatives, right? Route reflector or BGP configuration. So I'm going to talk about them one by one. When you go towards route reflector, what I do is, so route reflector is a sort of a client server. It's like a client server arrangement. What I do in that arrangement is, if I have, let's say, if this is an AS, and I'm just sort of building a little bit big network. Let's say I have these routers. So what I will do is, I will make, these are routers inside, and this is larger network as compared to before. So let's say before I was sort of, I'm having, so this is the network. If I want to build a full mesh, then I will sort of, connecting all of them. Right. So I'm not showing all of them, right? So, but I will make, those 6 into 6 minus 1 kind of those links, right? So many links. I want to transform that to route reflector. So full mesh. Oops. So full mesh. Now I want to transfer that to route reflector. Route reflector is also written as RNR. So what I would do is, as I said, it's a client server. So I would make some of them as servers. I will call them route reflector. So I would make route reflector 1, route reflector 2, and I would create adjacencies or peer shifts between the route reflector. So this is server as server 1, and this is as server 2, and this is like client 1, this is like client 2, and these are the two clients of this server. Let's say client 3 and client 4. So what I have done, I have divided my network into two parts. I can have one route reflector or more than one route reflector. So, and then these route reflectors, they will also be connected to each other. So the one thing you would notice is I have changed the IBGP of my AS, and I have preserved the original soul of BGP, IBGP. What? All the links are directly connected. All the links are directly connected, right? So you see from any server to any client or server to server, all those links are directly connected. So now all these clients, they don't speak to each other directly. If they have to send anything to anywhere from client 1 to client 2, they would send to the route reflector. And if it has to go from one server to the other server, that would go through the connection between the servers. So what I have done, instead of having many 6 into 6 minus 1 links, I am only having 4 plus 1, 5 links. So you see, I was having an issue of scalability, and I've solved it by doing route reflector implementation. By the way, that's a separate RFC. So for example, route reflector is RFC 2796. So the detail of all route reflector procedure is defined. Usually, if I do that, I would like to have, for redundancy purpose, I would like to have 2 route reflectors at least, okay, in there. And once I do route reflector, I do not need full mesh, right? Because I'm replacing full mesh. This is one option. The second option is BGP confederation. BGP confederation is brother or sister of subnetting. So usually, a couple of things about route reflector before I go. Route reflector has, practically, if you are an sort of a service provider, so your point of presence, you would have at least 2 point of presence. So there are 2 point of presences in every service provider, and you will have 2 core routers there, and they will serve as your route reflectors. Okay, for example, if you have this service provider and I have 1 point of presence here, the other point of presence here, and then they would be 2 my route reflectors, and then everyone else would be a member of them. But there is something which comes along with the route reflector is if by doing that, what we are gaining and what we are losing. Okay, so the problem with route reflector is traffic concentration to the route reflector or servers. Because if I'm not server, I would not talk on behalf of everyone. Not everyone would talk to me, but now everyone is talking. So this is sort of a compromise which comes with this. And its compromise is somehow addressed by BGP configuration. But the good point about that is, let's say, problem, and I would say good feature. So good feature of reflector is that is its scalability is better. So if BGP configuration, which I have to talk about, it solves this problem, but it is not good in scalability as compared to the route reflector. So it has a problem, then it has a good feature. So when we will cover BGP configuration, the second point would be clear to you further. Okay. So let's say now I talk about BGP configuration. In BGP configuration, what I do is, as I said, it's a brother and sister of subnetting. So what we do in subnetting is, for example, if I have, let me take the same example. So I have 1, 2, 3, 1, 2, 3 sort of these routers, and from full mesh, I'm not showing you full mesh, but full mesh, I want to go to BGP configuration. So what I do is, for example, I will be making, let's say, 2 groups. So I will make 2 sub ASs. So I will be making 1 AS. So I'll be making 1 AS. No, this is big. I'll be making 1 AS, and I will put 3 in them, and I will make another AS, and I will put 3 in them. So, and now let's say if this one is sitting at the border, and in here, this one is sitting on the border of these made up ASs. So I will build the link between them. I will build the link between them as an IBGP link. As an IBGP link, and inside I will have IBGP. Inside I will have IBGP. So I am one AS. Let's say I have a number. Black color. Okay. Let's say I have a number AS100. Overall, it would be AS100 to the outside world, as you have the same IP address in IPv4 for outside world, but inside I will divide it into 2 different sub ASs, which are sub ASs inside, but outside they are 1 AS. So I have a range in, I told you that 16-bit or whatever number was there for AS numbers. I have a range of ASs, so these are the AS numbers. AS numbers, which are like private numbers. As I told you, for AS, you have to go and register it, and you have to pay for that. Similarly, for IPv4, if they are available, you will go and you will apply for them, you will pay for them, you will get them. But there are certain private range of IPs which you can use for your purpose. So that range is also there in AS, and that range is 64152. It runs to 65534. So the ASs between this you can use to number these ASs, but I'm not using those numbers. I don't want to write the big numbers. So let's say you divided that AS100 into 2 ASs. That would be AS1 and AS2. So you said within my AS, I have 2 sub ASs, made up ASs. So, and they would be working as like made up ASs. So the link external between them would be configured as eBGP. And these internals, now IBGPs, I have choice. I can do, I can do either full mesh or I can do route reflector. So in green or black, now I have to configure IBGP. So IBGP, I can configure either with full mesh or I can configure with route reflector. So so for example, in here, I may go with full mesh, but inside this green, I may go with route reflector. So what I did, I have 6 routers. 3, I put in one hypothetical AS and 3 another hypothetical AS. On 3, I configured full mesh. On the other 3, I configured route reflector. And these were my internal topologies. And as far as external is concerned, I configured external as they would be to real ASs. So that's what I do in BGP configuration. So what I am gaining, again, I had what? Full mesh. So full mesh, I have to do all those links, right? I don't want to do them. So what I did additional configuration. What I did in my additional configuration is I made them in 2 parts. What I have avoided, even if I'm doing full mesh, I have avoided doing a full mesh of 6, and I'm doing 2 full meshes of 3 and 3, which is a huge saving. And still I'm preserving all the rules of IBGP that I should be 1 hop away, I'm 1 hop away. I'm 1 hop away in route reflector if I'm using, 1 hop away I'm using full mesh, and I'm not bothering 1 hop away requirement even by doing BGP configuration. So inside these AS1, AS2, they would work like, made up ASs. When they would go out, they would go as AS100. So I have defeated the bad impact of full mesh by making configuration. So when you look at the configuration, you'd see it would solve the problem of kind of the concentration of traffic overall in route reflector, right? But it also has a problem and it has a benefit. So I give you, just to summarize it. So it also has its own separate RFC. I can give you if you want, or you can search it up. So problem with this is, problem with configuration would be, it is complicated. You see, you're making, subnetting, as when you're a new student, looks complicated to you. Subnetting is a brother and sister of subnetting, complicated. Somewhat it's cumbersome. But the good quality about this, what is good about it? It got rid of that route reflector limitation, which is traffic concentration. In addition to that, it is very good for migration. So when the companies acquire, you see every other day, those bigger giant companies, they would buy new startup companies. So when I acquire a company, I want to make that company a part of my my bigger company. It would be easy for me to take in that company as under BGP configuration, because I can make my existing company as one AS inside, and I take another company and I would take that company as another AS, right? So I would say migration is more flexible. And let me explain that, what I mean. So let's say I'm a company. Let's say I'm Google. Okay. So there's a little company, ABC, and Google wants to acquire it, right? Just a rough example. So what I would do is I would say, okay, I want to make like, let's keep the Google the way it is. So I would say, okay, this is new Google. new Google mean after acquiring ABC. Inside, I will have two configurations. I will have one configuration, which would be ABC. And then I will have another configuration, let's say, which is old Google. So when you are acquiring a new company, so if you're a company who expands, who acquires other companies, and you don't want to mess up with the BGP setup of that company, you can acquire it as BGP configuration. And then, so if they have their external routers, then they can do this IBGP, and inside they would have IBGP. And IBGP, they can have any kind of IBGP, like full mesh or router protected. In your lab, when you do the BGP lab, you are doing both, right? So you are doing all the three. So first you would do full mesh, then you will undo that, and you will do route reflector, and then you will do undo that, and you will do configuration, so that you experience. If they have not changed the lab, so I don't know, sometimes they change, so that's what I advise them. That's what you would do in the lab. Okay, so I guess your seniors are here. Am I correct? I see Abhishek. Abhishek, you guys are there?
Yes, sir. We are here.
So not to hold. Yeah, I will. So Purva is there, Javelin is there. So I will divide you. I will take a break here. I will divide you in the breakout rooms, and you go on there. But let me do a few things before I do that. This. Okay. Yeah. So I will try to finish in a couple of minutes. Then I will do rest of the things later. There are two things I want to talk about, and I'll be needing another 15 minutes in the next lecture to finish this off. But I will send you this file after making PDF of this file tonight some point or tomorrow. So the thing I want to talk about is this, that if we are two ASs, I'm going to talk about the use of update source and multi-hop. So this is use of update, update should be together. Use of update source and multi-hop. So what usually we do is, let's say if I am an AS100, this is my best router. I am a green AS. This is my border router. I am AS200. Ideally, we have IBGP connected between these two interfaces. So these are IBGP is connected between physical. So this neighborhood, this peership is. Based on physical interfaces. But we may require that I want to make this not on based off. That's why, if you remember in the last lecture, I changed my saying should be rather than I said name maybe. What I want is, I want not this, but I want to have a TCP/IP connection between not here. So let me pick up some other color. So I don't want to have this here. Rather, I want to have a TCP/IP connection between this loopback and this interface. So I want to have my TCP connection here. So this is my loopback. This is a loopback, and this is physical. So let's say this is my home AS. This is home AS, and this is remote AS. I'll use the same color. This is remote AS. Okay. So if on the home AS, which is owned by me, not my service provider or any other organization I'm talking to, then, and I want not to use my physical interface, I want to use, let's say, a loopback address, then in my configuration, I will use an additional command, which would be update source. If I want to do red, then I will be using command. Oops, it's too big. Command, that should be. Why am I putting it here? Update source, that's keyword. Update source. Similarly, I have two other options. I have one option that in this, on my remote AS, I have, on my remote AS, let's say this is my loopback, okay? What I want is, I want to have TCP IP connection now between this physical interface. So I don't want to have now by here. Let me pick another color, this is not good. Which is more defining color. Let's say this one, yeah. So I don't want to do with this. So I want to do in this and TCP IP between this physical and this, let's say logical. Logical or beyond. So home AS mean I'm doing all the configuration here. So home AS mean I'm doing all the configuration there. When I have to this orange arrangements, then I will use the command called multi-hop. Multi-hop command, right? So, and I may have another situation where I will use, which color I have to use? Let's say I use this color. I would like to have a TCP IP connection from this loopback address all the way to this loopback address, right? Between loopback, or anything beyond this physical interface. So in this case, I will use both. I will use both update source on home site and multi-hop on remote site. And